What limits torque in a consequent pole magnetic gear? In consequent pole magnetic gears, torque is not limited by magnet strength alone. This study focuses on what actually limits torque in a coaxial magnetic gear design. Torque depends on how magnetic flux is guided, modulated, and constrained by ferromagnetic components. This study device is a consequent pole coaxial magnetic gear. Both rotors use a consequent pole topology. In a consequent pole design, all permanent magnets are magnetized in the same radial direction. This reduces magnet volume, but increases reliance on ion flux guidance. Torque transmission requires harmonic matching between the rotors and the modulation ring. This occurs when the inner and outer pole pair numbers satisfy the condition P sub I plus P sub O equals N. Only under this condition can steady torque be transmitted. Here, magnetic flux is concentrated in the modulation ring teeth and guided across both air gaps. Continuous flux paths confirm correct harmonic coupling. High flux density appears in modulation ring teeth, salient iron poles, and rotor yokes. Saturation in these regions limits torque before magnets do. Air gap flux density plots reveal the spatial harmonics responsible for torque production. Dominant harmonics match the expected pole pair interaction. This confirms correct magnetic field modulation. Torque is obtained using a static transient magnetic sweep. Torque is computed at each relative position. The torque angle curve reveals the pull-out torque. This design pull-out torque is equal to 9.4 Newton meter occurring at a relative angular displacement of 128 degrees. Design takeaways. In consequent pole magnetic gears, torque is governed by flux concentration in ferromagnetic parts. Saturation often limits performance before magnetic strength does. Flux plots and air gap harmonics are essential validation tools. This study demonstrates how electromagnetic simulation can be used to identify torque limits early in the design process. Long results were obtained using EMWorks EMAG. The full application note is available online. Thank you for watching. Bye.